we have on the line here is Alan, who works for HPE as the Enterprise 5G Lead Architect. He has been involved in architecting HPE's 5G solutions, and at the core, we would like to think of the product is Apache Ignite. And so he would like to talk about building cloud-native 5G network functions with Apache Ignite. Again, just as we did with Shai, we'll have some time for questions at the end. So if you have questions, please do drop them in the chat. Remember also that we still have the booths to the side of the screen. If you have questions for our experts, we have a couple of people ready to answer your questions. Otherwise, sit back and enjoy Alan's talk. So thank you. Over to you.
So hi everybody. So Alain Guigui from Hewlett Packard Enterprise. So thank you for organizing this and give HP and I the opportunity to talk about what we are doing around 5G. Actually, it's a very good, and simple transition from the two previous presentations, because we're typically in a big transformation into the telecommunication networks, and I will try to explain why. And typically 5G is driving really a kind of transformation to cloud, and basically we are a very specific use case. So as Sherry did explain very well, we've been really focusing while using Ignite on typically 5G use cases. So what they are actually, because one thing that is interesting is that 5G actually basically so I'm going to explain a bit of the requirements, right? And then I will drill down into why and how we are using Ignite and share a bit of the experience. Where that's going to be the agenda of this press. But essentially, 5G, people tend to think that it's going to be yet another, generation of network, and it's going to be a better bandwidth, it's going to be better QoS, blah blah blah, right? And people tend to think that it's going to be, kind of new for consumers, right? But actually, the 5G premise actually is essentially different. And basically, while it will be also applied to public networks, and you will see, you already see 5G phones actually, and you will start to see the emergence of 5G networks. Actually, 5G has been designed essentially to provide, to enable new kind of use cases. I'm going to pick up a few of them actually. So what we're going to see with 5G is the enablement of remote surgery, remote diagnosis, etc. It's going to be, virtual reality, augmented reality. It's going to be Industry 4.0, actually, completely, autonomous, factories, automated factories, connected factories with 5G typically. It's going to be smart grid. There are a bunch of use cases that do exist today, but with limitations, right? And when we think about 5G, typically it will enable those new kind of ultra low latency use cases. The major difference between the 4G and previous generations and the 5G generation, the 5th generation, is going to be ultra low latency use cases and ultra reliable use cases. Okay, so the way the network has been redesigned actually is done in such a way that they're trying to achieve those two main objectives, and this is what we're going to keep in mind during this presentation. Because when you think about remote surgery, when you start to remotely operate, practice some surgery, you have to be really real time. And you have to be ultra reliable. There's no way the infrastructure and the network in between can fail during a remote, surgery operation, right? And many use cases will also require this kind of ultra low latency. So when we start to think about that, what we see is that 5G will also emerge as something more dedicated across verticals. Typically, there will be, a new notion that is called the slice, notion, where we're gonna tie the network, tie a logical network on top of a physical network, and apply it to a specific vertical with specific QoS properties, with specific charging, with specific properties and networking properties to guarantee the latency and to guarantee the availability, typically. And so we're going to have a slice for, a vehicle, autonomous vehicle. We're going to have a slice for healthcare. We're going to have slices for smart grids. We are going to have slices for factories, etc. And what we see also is that to achieve this ultra low latency, because I've been hearing about, single digit. Actually, for some of those use cases, we're gonna go, below. We're gonna go below sub-millisecond. Okay, we're gonna be around, 500, 600, 700 microseconds actually on the user plane, right? So it's something new compared to the previous generations. So to enable all of this, actually, what we're gonna see is a major change and transformation into the network. Actually, today, if you look at telecommunication network, they are mostly centralized, right? There is a core network, central. There is a radio access network, a set of radio access networks, but the RAN is distributed, but the core is centralized. And it's going to change, because if you want to achieve those ultra low latency, even the core network, and I will explain what it is, has also to become distributed, and it has to become flexible, because with all those use cases, you want to be able to enable the use cases very fast. You want to scale those use cases as you need, right? Because typically for operators, the world will become really more complex than what it is today. They're going to address many more enterprises than what they do today. They will not talk about, a bunch of big ITs, being connected, being served by a 4G network. We're going to talk about 1,000 enterprises being served by a single operator. It's not more, actually, right? So, long story short, ultra low latency, massive distribution, and massive transformation of the network. All of this makes the ground to make a cloud native transformation, right? And typically, the 5G core network has been really designed and redesigned actually by normalization, by standardization committees, etc., with something where actually we can really deploy either in a central cloud, or also starting to apply the cloud, practices across the board from the RAN actually to some edge clouds, to the core network, and even to the application level. Compared to the past, actually, when we look back, 10 years ago, pretty much, everything was centralized again. Okay, so what we start to see as a first step, actually, what is very interesting is that we start to see this big transformation occurring in the core network. And the core network, typically, to summarize, is the brain of the network. It's what performs the authentication of devices. When you switch on your device, typically you start to authenticate with your SIM card. An example, the core network also manages your mobility. So when I need to call you, or when a device needs to connect to me, actually, something in the core network knows where I am. So something does manage my mobility, actually. And then there are a bunch of other, functions, typically session management. When you open up, a data session, such as, watching a movie, for instance, or typically in the future data sessions for remote surgery, you will have specialized session management functions, along with policy management functions that will enforce a very specific QoS, actually, to ensure that the required QoS is guaranteed, even though there are, competing use cases on the same network, on other slices, okay? And then you have the so-called user data management, where you will find typically an enterprise profile, an employee profile, or even you as a consumer, a user profile. And what characterizes a telco network, it's low latency, reliable, and with 5G, it will go to very small scales, because when we will start to see the emergence of what we call private 5G, so you're gonna see a 5G in a box kind of offers, emerging on the market to serve SMBs, enterprises, hospitals, and it will start from those very small scales up to very large scales, where we will serve typically tens, hundreds of millions of users. Typically, we have countries where a telco network can serve, 100 millions of users on a single network. So, in essence, what we need to achieve is something where we have the flexibility, we have the latency, and more we have the management operations that are aligned with those changes. And I'm gonna drill down a bit more into what does that mean to us in terms of real transformation. So if we look at the current application stack, so especially on the cloud native, on the typical cloud native stack, what we see is that there is potentially always an infrastructure as a service. It can be OpenStack, it can be VMware, it can be AWS, it can be whatever. Actually, we're going to see some CAS-PaaS, and typically this cloud infrastructure, what we see, and it was quite interesting in the former presentations, what we start to see also emerging is the notion of multicast, multi-cloud, because and it's a big transformation to operators. Again, think about, everything on-prem, everything centralized. In telecommunication, we operators are still in this kind of, mood actually, but they are, progressively transforming. It's going to take years probably, but they have started. So what we start to see in terms of cloud infrastructure, it's going to be multicast, it's going to be multi-cloud. We'll see some workloads, on premises, in private networks. We'll see some workloads even on public clouds, and it's going to happen more and more actually. And again, we will also see, private, public, hybrid kind of deployments. So meaning that in terms of cloud infrastructure, we will embrace, all the current practices, and we will embrace them into the telecommunication landscape. This core network is composed about, those functions I did explain actually. But the big transformation here is that if we look at, 4G design, those functions have been designed monolithic. They pretty much all embed their own database. Okay, they are monoliths. Okay, and so they are hard to scale, they are hard to operate. VHA is very costly. Trying to reach, a good level of availability is extremely costly, because when I hear, blue-green, it's basically we are still in the mood of active standby actually at this stage. But to reduce costs, they need to really embrace, in fact, cloud-native practices and cloud-native design patterns actually. So what we start to see is that, and the way we are building even our 5G functions, we are making them completely stateless, trying to apply, in fact, the so-called 12 factors. And to achieve the requested level of availability, because typically in a telco environment, we need to reach 5.9, right? 5.9 means less than 3 minute downtimes a year, okay? Even on a very large infrastructure. And actually we turn towards, even 6.9, so which is less than 3 seconds downtime, okay? So we are designing our functions in such a way that they're completely becoming stateless. They can fail fast, and their recovery is completely automated. Because as Shared explained very well, when we will deploy 5G network, it will not be, a couple of instances. We are talking about thousands, 10,000s of pods. Okay, so meaning that, and those pods will fail. So meaning that one of the major change is that we were designing against failure. We were designing, trying to prevent any kind of failure in the past, as opposed to in 5G and in this new paradigm trying to design for failure. Because we know for a fact that on Kubernetes, pod will fail. But it means that the services still need to be there, right? And to achieve, in fact, this level of availability, what we need to have in the mix of the architecture is a cloud database that is highly available and that does provide very high performances. So with this, stack, what is very important is that we're able to automate, in fact, all this stack from the deployment of the IaaS, CaaS, PaaS, as well as from the deployment of those core network functions. It is becoming very critical that we automate, in fact, the whole stack from the deployment, provisioning, configuration, operations, and even end of life, right? And as well across the life cycle, of course, when we scale, etc., it has to happen as far as possible automatically. And actually, with this, kind of new pattern, it has started actually in a couple of networks, and what we've been achieving is that a North American, telco has been able to define, execute, an end-to-end deployment and test in 4 days. If I step back for a minute, 10 years ago, it would have, taken, months to get there, right? To plan, to design, to deploy, to configure, etc., etc. It would have really taken months. Now it takes, a couple of days actually, and it will take even less, in a couple, probably in 1 or 2 years, because as we progress on automation, it's gonna become, probably a question of, a minutes actually. So if I drill down a bit, on what we're doing at HPE, we are doing, this 5G. We are developing, in fact, the functions that do constitute, the 5G core network actually. But essentially, we have been, so all the access and mobility functions. Here you see VMF, the session management functions that is called VSMF, etc. All of that are relying on a specific repository, so where they can store, in fact, their own data. So they are not anymore monolithic. We are really applying, the so-called, client-server design pattern, but in a cloud-native way, meaning that they can store their state, they can store their data, so they can fail, and when they fail, they can retrieve, in fact, their state and continue the activity, and this activity should be transparent to the end user. Typically, we are developing what we call a UDSF, and the UDSF is the backend for those kind of real-time functions. And if we look at its properties, basically this UDSF is really supporting the transformation into stateless functions, because today we are developing the new functions, but we are also transforming the existing functions. Typically, the so-called home location register and HSS, home subscriber servers that we were finding in a 4G environment are also transformed into this cloud native new paradigm, but they need a backend to do that actually, and they need a high performing backend. This backend typically in terms of workload, it has to support, massive writes, but because when we start to store session data, as an example, we are talking about, essentially creation, deletion, and updates of sessions, and we talk about millions of TPSs, and all of that into a 5.9, with a 5.9 availability, right? And we are building a second kind of function, which is the UDR, and actually, to accelerate a bit, I will talk about the 4G UDR and the 5G UDR because they are pretty much the same. It's just that those functions are pretty much, hosting the user profile. So typically the user profile is where you find, in fact, your services configuration for end users. This is where you find, your roaming authorizations. This is where you find your SMS authorizations. When typically when you go into another country, you're allowed to go in this another country and you're allowed to connect. It does not happen by magic, actually. Once you connect actually in the core network to a database that does store and handle those kind of authorizations and all the corresponding configurations. This is called the UDR. And when we look at the UDR, typically from the standpoint of a database, the workload is pretty different actually. It's mostly read actually. You consult in fact and you update from time to time. But it has to handle from very small deployments to hundreds of million subs. And typically it has to provide sub-millisecond accesses. And again, 5.9 availability. The 4G UDR is pretty much the same, but as opposed to be to offer, a REST interface, it does offer, because of legacy protocol being normalized, it does offer an LDAP interface. But from the standpoint of the workload and the database aspect, pretty much the same. So we are building all of this in HPE, and I'm going to share a bit the experience and to achieve and why we did select the Ignite actually to build those functions. So why Ignite? So as you've seen, we needed, ultra low latency, meaning single digit, right? So in read and write. So, and the max latency to us is probably something in around 5 to 10 milliseconds, the max latency, but the average latency should be more around 2 to 4 milliseconds and even less. And in some cases, the average latency should be in read sub-milliseconds, right? So we needed a database that was in memory first, because the only way to achieve such ultra low latency was to rely on in-memory first and massively scalable, because again, we will start from very small and be able to go very, very large actually. We needed also something with a local high availability, with a good resiliency, properties, configurable case safety, meaning that we needed a database where we would be able to decide the number of local copies actually. That was very critical to us, because in typical deployments today, when you don't have multiple local copies, you have only one as an example. It's not only that you have a single point of failure. It's in case of failure, you need to fail over to a different site, which is a very heavy and risky operation for an operator when you have millions of subscribers being connected. You don't fail over like this, right? So to us, local availability was a very critical property as well. And then, some kind of, a persistent database, because if you look at the, I would say the session management, pretty much in memory, because they are highly, volatile, context, changing pretty much every multiple times a second, so no need to have a persistency. But when it comes to profile data, we needed something persistent, because when you provision all those user profiles by millions, tens of millions, if not more, you need something persistent. And what we wanted to achieve is something where we would be able to use one single database, not multiple. Right? I know that Ignite from time to time and very often is put as a front end to other database, but that's not something we are looking at actually in the telco space for our applications. We wanted something easy to manage, consistent, a single database, right? Cloud native, of course, because as you've seen, we are also transforming the core network and the whole network actually, around the cloud, going cloud native. So typically, we needed something that we would have been able to deploy on a plain vanilla Kubernetes, OpenShift, AKS, EKS, Wind River, and so on, because there is also Tanzu in the list. There are multiple. Actually, what happens in the telco space is that the infrastructure to telco operators is a pretty big investment. So they do select, some reference vendors. They do rely, on specific vendors. And when they want to combine, so they select OpenShift as an example. It becomes their reference, CAS pass, okay? And then they want to apply it to everything. So, and every single operator is different. So to us, it was very important to be able to use actually multiple, CAS pass technologies. And within the trend of multi-cloud, it's also a kind of, a key enabler actually, because when you start to think multi-cloud, most of the time the cloud, those, multiple clouds become completely heterogeneous. Of course, I will not depict the, some of the core, DB functions, well-known interfaces, asset support, flexible data types. You will recognize some of the salient, existing Ignite properties. So before we've been using Ignite, we've been doing a pretty intense selection, guys. I'm sharing with you some of the, candidates for us, Aerospike, Hazelcast, etc., Maria, Volt, and a couple of those. Okay, and what we found. And what we've done, during this evaluation is that, first of all, we've done a bit of paper evaluation. And what is great with Ignite is that there is a lot of data on the web. I invite you, when you select a database, I really invite you to look at benchmarks, academic publications, because Ignite is very present. It's very well documented. We've done some benchmark, actually. We've done a prototype, okay? And we did, early performances, tests, actually. Before developing our products, we've been through the prototypes. We have started to assess performances, because again, to us, it was knowing our use case and knowing our workload, trying to achieve ultra low latency, such as around let's say the 1 millisecond time frame, was something very, very critical to us. So we've done a prototype, and then we decided to go with Apache Ignite and actually Gridgain, to be fair. And then we have issued a first version of the product. So if I look at a bit more in depth the architecture, and I'm going to share a bit, across, the explanation of this end-to-end architecture, a bit of the experience. So as I said, we needed, something that was supporting multiple CAS paths. Okay, and what we found at the very beginning, but remember, guys, it was 2 years ago. Okay, so what we found is that Ignite was very great, from the standpoint of being, cloud ready, being available on Docker, etc. But the adaptation to OpenShift, typically 2 years ago, has not been very straightforward. Okay, it has required a bit of, effort to us to automate, in fact, the deployment, and also to get, the liveness, readiness, working properly. Because from time to time, we found a couple of, issues. No criticisms here, it's just sharing a bit of the experience. So we have a bit, work with Gridgain to robustify and share our experience. And actually, we are getting, very fast, responses, etc. So we are very happy with that. And then from that, we've been using basically Gridgain as an hybrid environment, first in memory and on disk. Okay, and then we've been building those functions, and we've been adding a couple of, additional functions that we could not find, in Gridgain. I will not drill down into all of them, of course, but the typical things that you would find, to build, a telco business logic, such as, overload management. Okay, so typically what we found at the very beginning is that there was no, protection mechanisms, that was suitable, for a telco, great deployment. So we've been developing some overload detection and overload management capabilities as part of our, core network functions when using Ignite, to avoid, overloading Ignite. We are protecting, we are kind of shielding Ignite to make sure that those, UDR, UDSF functions are available and they answer with a guaranteed latency, because again, it's very critical into a core network. And then a couple of additional functions that were needed, in fact, in the core network, subscription, notifications, etc. and a bit of a specific, data center replication that is really real-time continuous, because we need to be able to replicate, at the time any update comes. It's completely atomic and linked to the subscriber profile, because what is very critical to an operator is that when we start to have redundant deployment, the user profiles, data keep, its consistency across the multiple sites. So to us, we needed a very specific replication mechanism that we've been developing ourselves. But what was interesting with Ignite is that I think shared, in the previous presentation, I would really basically encourage and reiterate, his advice. Use operators, and typically use the Ignite operators, because for the life cycle, it will simplify your life, actually. And that's what we've been doing, actually. So, actually, we are now leveraging and enriching, in fact, this operator to be able to deploy our functions end-to-end. So there is one single operator that does manage, the Ignite part and the functional part, actually. So when we deploy, it's completely automated. When we scale, it's completely automated. When we upgrade, it's completely automated, right? And then across the board, we've been developing the integration towards the so-called, cloud-native observability with Prometheus, Kibana, and all the likes, actually. And we've been using some key native, Ignite capabilities to achieve this. We are still using mCharts, but I will not go into details. The key message here is that Ignite has had all the good properties to enable such a cloud-native architecture from the start. Okay, so it did allow us to develop those new functions in 1 year, 1.5 years, which was, compared to the past, a pretty short life cycle in the telco space. Because usually in the telco space, when we develop, new core network functions, typically when there is a new generation, it takes 2 to 3 years, actually, to develop beyond the network from the initial design to the deployment into real production at scale. Okay, because there are so many steps, and when we have, hundreds of million subs, you need to make it work, right? So what we've been achieving so far, bouncing, on Nikita's presentation on the, one box kind of deployment to us, what was very critical is that we needed to achieve something with, a massive throughput, actually. And when we talk about throughput here, it's a throughput, per box, actually, that we were trying to achieve first. Because with Ignite, the good thing is that you can scale pretty much horizontally. You can add nodes in your cluster and then it scales. The performances, the throughput is basically scaling. So to us, when we were developing our own, UDR, UDSF functions, what was very important is that we could maximize, in fact, the throughput per box, actually. And what we see today with, very standard servers, industry standard servers, is that we've been starting with the former technology at 10,000 TPSs, okay, per box. And now today on an equivalent function, actually, if you look at the UDSF as an example, we are around the 40,000 TPSs per single box. And when I say single box, it's a 40 core industry standard servers, actually. Okay, and actually we are going even higher with the UDR function, and it's quite double actually today. And we are on the way by using again, some key salient Ignite capabilities such as peer class loading, etc., to increase in fact this throughput even more, actually, right? And what was interesting is you look at the details of this workload is that the left side typically is a mixed workload where you have a lot of what we call write operations. Okay, if you look at the details, the create, the update, and the delete are a vast majority of the workload. Actually, they are pretty much 70% of the workload. 70% of the time we write. So pretty much everybody can do it over the weekend to do a pretty efficient database in read. Okay. Some of them, a lot of them do exist on the market. The ones that are really performing in write are really a few, and they definitely Ignite is one of them. Okay, and again, what we needed to achieve is something around the throughput, but as well something around the latency, actually, right? So if I share a bit the results today, when we started with the 2 years ago, actually, well, pretty much 1.5 years ago, to be honest, right? We had latencies around the 10 milliseconds, okay? And progressively, we've been really decreasing, in fact, the low latency. And what you can see actually, if you look at typically the mean latency or the average latency, no, we are more around the 1-2 milliseconds. Okay, if you look at the 2020 results, and they are even better today. Actually, I can share a couple of additional results for people interested. We've gone sub-millisecond in reads with the latest releases of our product, right? And so those two things were key to us when we've been selecting Ignite. And Ignite does really enable us massive throughput, and the massive throughput help us to reduce the overall solution footprint. But at the same time, again, irrespective of the workload, with massive writes or reads, reaching ultra low latency. And because of this, now we are enabling, a new paradigm in the network, actually, because I'm going to talk a bit about the cloud native, design benefits into a telco environment. The equivalent in 4G of an access and mobility function, typically when it fails, generally it's a monolithic application, and it does handle each instance in the network does handle around 15 million users at the same time. Okay, so when it fails, it means that all of a sudden those 15 million users are disconnected from the network. That's when you get a no service, at the top of your mobile phone. Okay, so when it fails, again in 4G, when the equivalent of this access and mobility function that is called an MME fails, you have 15 million users disconnected all of a sudden, and again they have to reconnect. So it means a storm in the network. Okay, it means an extra load in the network, which is very difficult to manage for an operator. Okay, so what we've been trying to achieve with this new, cloud native design pattern is something where those functions would become stateless, and they would store their state actually into a dedicated backend that is called a UDSF actually. So when they fail, typically when an AMF fails or a session management function fails, the state is stored into the UDSF. So the AMF and the SMF can restart in a few seconds. Typically, if the corresponding pod fails, they can restart in a few seconds. And then they retrieve their previous state, and then they continue to handle the traffic, right? That was one of the primary objectives of transforming into those core network functions into stateless functions. And it was one of the primary benefits. So today we've been able to demonstrate and achieve those kind of results because of this UDSF actually. And this UDSF with massive throughput, because typically when those functions are storing their states into this UDSF using Ignite, we are talking about millions of TPSs for a single instance. Okay, and we have multiple instances of UDSF to serve a full core network with hundreds of millions users actually, right? But the net benefit in terms of end-to-end experience is that the users, the end users, so typically you with your mobile phones, don't see this failure anymore. You don't get anymore the no service actually, because the recovery is going so fast with this cloud native design that the user equipments do not have to reattach to authenticate and to reconnect actually, basically. Okay, so meaning that we are enabling a continuous user experience. So meaning that the failures are becoming completely transparent. Okay, and because you have no longer those signaling storms, right? Those reconnection storms, the operators are becoming, able to size and to plan for a network that is not linked to peaks, but that is sized, as a function of the average load, which is a massive saving to them compared to the past design. And typically with the transformation of the telecommunication networks and the landscape in general, where you start to see hyperscalers also providing communication services for telcos, CSPs, operators, it becomes very critical to reduce, in fact, to become more effective in terms of cost, footprint, CapEx and OpEx typically. So the automation and the reduction of footprint is allowing them to provide a seamless experience while still being competitive on the market. I will end with that, a bit of the next steps. So we are collaborating very closely with Gridgain actually. So we will complete the Kubernetes readiness. We are working with Gridgain on stable checkpointing, because we have been pushing the persistency a bit at at its limits. but it's part of any product improvement, right? And we are very happy to work with Gridgain to help, because what we think is that the more we share, the more it's going to benefit to the community actually, and at some point in time we would be even glad to also contribute to the community actually more directly, right? And then we will go into large scale production very soon, okay? Because normally the first go live should be in January actually. So improved tuning and profiling, especially across the persistent storage usage. Share, did you share, a very, relevant, remark on the storage? Take the fastest as possible. I think I would completely agree with that first, right? But I would add to that it's also the IOPS that should be guaranteed. So the IO, so input outputs, per second, that should be guaranteed. It's not just a question of having the fastest SSDs. It's also a question of when you get access to those, storages, the IO has to be guaranteed actually. So because most of the time in a cloud infrastructure, the IOs are shared, right? So it's very critical, especially to reach those massive throughputs and ultra low latency, to make sure that the IOs can be, guaranteed. So we will, do some reference storage, characterizations on AWS, on Azure, with also HP specific storage, right? And then we will continue to progress on orchestration and lifecycle automation. Basically, our goal is really to prepare for zero touch, right? Because again, bouncing on Cher's presentation, when you have, thousands of instances, you can basically not anymore, operate, and that's not the spirit of cloud native. That's not the spirit of, Kubernetes, right? You have to be zero touch actually. You should not change the configuration in the pod, right? It's immutable. It's kind of immutable infrastructure. If you need to scale, you add resources. If you need a new version, you need to change the configuration. You issue a new pod, right? You should not, modify any pod. So to us, to reach this level of availability, latency, and simplicity in operations, we have to prepare for zero touch. And then what we are preparing as a very last step, and it's going to start probably middle of next year, probably along, the next year as well, the year after, it's embrace, the new Ignite, capabilities. We know for a fact that there will be a new SQL engine. We are very excited about that. We know that there will be, new kind of storages such as, LSM trees that are supposed to be, more, suited for massive write workloads, Raft rebalancing, etc. So what we plan to do is to use the beta, as the beta versions as they become available, and start to leverage in fact those kind of new capabilities. And as well, like Nikita, basically explained, we will also, embrace the upcoming, hardware changes along with, I'm talking about memory, with Optane, etc. And we are very glad that Ignite also will support this, but there might be GPUs for some very specific workloads. I did not talk about those workloads here because I've been focusing really on the core network, but there will be more and more analytical, kind of workloads, surrounding the core network to be able to analyze, to be able to personalize, to be able to shape, etc. So we're going to use, in fact, those capabilities that will come through Ignite to us. So I will end with this. And again, I want to thank you guys to organize those great sessions. If you have any questions, then you're very welcome. And of course, if you want to have questions later, you have my email. Just send me an email. I'll be very glad to answer any questions.
That's great. Thank you very much for your talk. It's kind of good to hear how things have progressed. I last worked on mobile phone stuff in the late 90s, cell broadcast and SMS. Things have moved along quite a lot since then.
Yeah, sure.
So I think we're a little bit over, but let's go with a couple of quick questions, and then if anyone else has other questions, we know how to get hold of you. So I guess the first question is, will 5G become the in-campus network capability replacing Wi-Fi?
That's a great one, actually. Yes and no, actually. What we see is that we will rather see a convergence of 5G and Wi-Fi 6. And typically, if you look at the 5G core network technology, It's a multi-access technology. It has been, designed from the start to provide access to Wi-Fi networks, to mobile, to wireless networks, whatever they are, 4G, 5G, 3G, all generations actually, and even, wireline networks actually, right? So it's not going to be either or, it's going to be more, a convergence. On the campus, typically, you will certainly see still a lot of Wi-Fi deployments, but in factories where we need, guaranteed ultra-low latency, typically, you will rather see, private 5G kind of deployment. So it's going to be a mix, actually. It's not either or, it's both.
Great. And so I think maybe the last question for you today is from Boris. You evaluated Ignite and Redis. Why did you go with Ignite and not Redis? I mean, obviously, we think it's the right choice. But...
Okay, fair one. No, fair one. One of the key things, right? With Redis, our problem was at scale. The scalability, the response times and the throughput, versus scalability. Okay, the more we were scaling with Redis during our evaluation, the less we got throughput actually, right? So meaning that it was not really scaling linearly at that time. It has maybe evolved, but at that time it was not the case. And to us, it was very critical to have something where we could start very small to very large. Okay, and so that was one of the reasons. Then the second reason is that they changed their license model. It was 2 years ago, right? And to us, it was a killer. Okay, because to us, what is critical is that we can. It's a mutual collaboration where HP can develop IP, intellectual property, contribute to the community as well, and those two things should a bit remain separated, if you will, because Gridgain and Ignite can have their own life, and HP can have its own life as well, right? Because when you have licenses that are viral licenses, then it becomes very difficult to develop intellectual property. And again, we are in the business of a telecommunication network. Okay, typically it's not sold for free, right?
That's very true. Okay, well, really appreciate your time. Thanks for that. Hopefully you'll stay around and kind of watch some of the talks.
Sure.
Coming up.